Welcome to my talk. My name is Cody Burkard. I'm going to present today about a vulnerability I found within Azure DevOps. And I think this is a pretty cool vulnerability because you can use it to escalate into Entra ID, take over a service principal, and kind of change your security context. So now, a word of warning, this is a technical issue, and I don't have enough time in 10 minutes to go over all the technicalities here. So this is going to be more of a warm-up talk for you to go read a blog post if you're so inclined that I will link at the end of this talk. So normally what I would do in a talk like this is slowly build the audience up to some kind of quintessential moment where I actually get the exploit to work. But today we're going to do the opposite. So this is the actual results of this exploit, what you see on the screen. You can see this is my server. Where's my pointer? There it is. This is my server. And I'm printing out the logs on the screen. And on the screen, you can see an access token in the logs. That is coming from Azure DevOps, and that is not my access token. That is an access token for a service principal with an Entra ID that I should not have access to. So the question is, how did we get here? And that's what we're going to work towards today. So really quick mandatory who on my side. I'm Cody Burkard. I'm a cloud security researcher based here out of Oslo, Norway. My background is in web application security testing, Azure Entra M365 testing. I've been doing that for about 8 years. Today I do that under my own company, NDC Security, where I offer both security testing and advisory services within cloud security. That's all about me. Moving on. Today our target is service connections within Azure DevOps. And if you don't know what that is, that's essentially a container for authentication from Azure pipelines to be able to deploy to some backend target. And specifically within here, the target is Workload Identity Federation, which is a specific type of credential. That is OIDC within Azure DevOps. And why would you use that type of credential? It's mostly so that you don't have to manage secrets. Secrets are easily leaked, and you have to roll them, and it's kind of an operational issue when you use them. So Microsoft now recommends to use Workload Identity Federation instead. So how does that work? Well, when you create a service connection, you get these two fields, a subject identifier and an issuer. You plug those into the federated credential and a service principal, and that establishes a trust between that service principal and that DevOps service connection to allow it to take over the service principal's permissions. Now, the full login flow here is not too complicated, really. This gets performed from a build agent. And that build agent is what's running the pipeline that has access to the service connection. So the first thing it does is it's going to call an OIDC issuer, so the DevOps issuer here, to get an OIDC token that's signed. It's going to then try to log into a service principal using that token in something called a client credential grant. Entra ID will validate that these two values are the same that have been configured here, the values that they received in the token, and that it has been signed by pulling a public key from the issuer and verifying the signature cryptographically. Once that succeeds, it returns an access token for the service principal, which can be used against the backend target. So this is the full technical flow. But for our presentation, the most interesting piece of it is really this top bit here. What is in that OIDC token, and how does it get there? So this is actually pretty straightforward. There's really only two things for this presentation that are interesting, and that's the issuer and the subject fields, which we actually just looked at in the other slide. Those are the two that you configure in the service principal federated credential. And the issuer is just the authorization server. That's the server that signs the token and also has the public keys that you use to verify. The subject, though, is the most important for this presentation, and the subject is always an ID that's specific to a service connection, and that's very important for this vulnerability. So this is different than, for example, in GitHub. GitHub, you can have a subject that would be, for example, a branch, or it could be an environment, and so you can kind of differentiate which branches can perform this flow. In DevOps, it's different. It's always just the service connection. So that's enough of background. Now we're going to get a bit into the actual vulnerability itself. So the vulnerability, funny enough, is in this little tiny button on the bottom here, verify and save. Fairly innocuous, but what happens when you click that button is DevOps will try to log in with that credential and then check to see if it's actually working, right? So you can infer a few things based on that. You can infer that that whole OIDC flow and login flow that I just showed you actually happens. And you can also infer that a token is sent to the backend resource to check to see if it has access. Now, as a security researcher, I was actually playing with this because I wanted to find a way to abuse this and extract tokens for pen testing. But when I opened up Burp and I started looking around at the requests that were sent, when you click that verify and save button, you get this request, service endpoint proxy, which is by itself kind of a weird endpoint. And specifically, you have this field in here that stood out to me like a sore thumb. Why is there a subject that is being sent by the user to the server? Because the subject should always be known based on the service connection that you're logging in with. So that should not be in the request. And if you can control that, you can actually potentially spoof which service connection you're logging in as. And that is exactly what I did. It turns out that there's no verification when you send that, and they just use that to establish the first OIDC token. And that breaks the fundamental security promise of this whole setup, where an attacker should never have control over that OIDC token subject. So what does that broken promise mean? It basically leads to privilege escalation, because you can now impersonate any service connection within DevOps. And in the real world, oftentimes, companies will have many different service connections with varying levels of permissions. So if we look at this example, in this architecture, you have two service principals on the top right, the little dots that are federated access to a service connection via that process I showed you earlier. And this is actually a good architecture because those two are isolated. They can't take over each other's permissions. But because of this vulnerability, an attacker that has access to a low privileged service connection on the bottom can call this endpoint with their own subject, spoof the subject, and spoof service connection A via that subject. Essentially logging in as that service principal and taking over its permissions. Now, this is almost the end of the technical part of this. This is almost the end of the talk, but I don't have time to detail the next piece of this. This is only the first half of the actual attack, because the result of all of that is that you're able to spoof the OIDC subject, but that token is still going to be sent to the backend resource, such as the Azure Resource Manager APIs that you don't have control over. So how do you actually abuse this if you know that you can spoof the subject but not get access to the token? And you'll have to read my blog post for that full adventure. But in the end, I found an SSRF in the same exact endpoint in this specific parameter, where I could specify a website that I owned. And I could also specify a subject that I wanted to impersonate, force Azure DevOps to go through that full flow that I described before, and at the end, forward the access token that it fetches off to my server, which brings us back to the beginning of the presentation. So that is an access token that I basically forced Azure DevOps to send me via this spoofing attack. If you want to know how that all works, then go read my blog. That is on the right side here. I published it like an hour ago. So it's brand new. This is the first time I've actually publicly disclosed this, but this issue was fixed in September last year. Microsoft actually responded within about 1 month, about 45 days, I think. So that was actually a pretty good response time. They fixed the subject spoofing issue, but that endpoint is still full of SSRF vulnerabilities. So if we have any aspiring bug bounty hunters, there's some free cred there if you guys want to go exploit those. If you want to connect with me, this is my LinkedIn, or if you don't want to scan a QR code, I understand. Feel free to use this one up here. And that's me. Thank you.